Hi everyone, I want to share this project with everyone so that maybe someone will jump in and give me some help, because I need a schematic on this Hammond November-322. I can't find any schematics on it or any kind of manuals whatsoever, and I've Googled like crazy. Let me show you what I've got done here. So I took the power supply and the amplifier board out. That was quite a task. As you can see, I've labeled most of these wires here because they plug into some pins. There's a few of them that I missed, but they're just speaker wires. So that's pretty straightforward. And there were some that I just cut because I'm not going to go all the way up into this upper board and unsolder anything, or I thought it'd be easier just to cut it off, and it's pretty self-explanatory where they go because they're colored and they're twisted. Let me show you what I have found with this amplifier power supply board here. I got this organ free for the taking, and they said it needed work, and they were right, it needs work. So we look down here, you can see I got a part that burned off, and when I plugged it in and tried it out, it started smoking right away. But it's not a really complicated circuit. If you look at it, you see some diodes in here, and I'm pretty sure this part that burned out was a diode, because it looks like it's a combination of 4 diodes that create a full wave bridge. And then you see a couple of other diodes here in the middle. One side comes to a point and the other side goes to some secondary windings, so that's a half wave bridge there. And if I show you here on this amplifier circuit, here we got 4 power transistors. They're all the same, they all have the same number. They're some I think they're NPN germanium transistors. And what I found was that it's just 2 separate amplifiers. You got an output driving a Leslie speaker, and then you have another output driving the other main front speaker. So they're just distributing the load right there. I don't know if you can see this here, but if you look at these wires right here, we got a plus 25 volt and a minus 25 volt insertion point here. And if you look at these capacitors here, I'm pretty sure they're the same value. And you see one is insulated, it's got a paper coating, and one is not. And as you know, these capacitors, the shield or the outer casing is actually part of the capacitor electrically. So what I'm sure they've done here is they got 2. This is the one of them is the negative 25, and one of them is the positive 25 volt power source. We'll take a look under here, and they got center taps from the transformer here going to this one transformer, so it forms a common point for these center taps. And also if you look closely here, this black wire here, the one black wire is connected to the outer casing of this capacitor, and then it's connected to a point that's not the outer casing, which is, I don't know if it's positive or negative. I'm thinking it's positive on this capacitor and negative on here, because this is tied to chassis ground, and it's electrically connected to chassis ground. So they're making the chassis return point for both the positive and the negative. Now, another thing that they do here is on one side, the negative side of this 25 volt here power source, they got it running to this transistor, and I'm not 100% sure what the number is on this, because I wiped it off trying to clean it. Some mice have been in here, or rats, and I cleaned this up the best I could, and in the process I wiped off the number. But it's kind of looking, I looked at the numbers, and it's sort of looking like it's the same as these amplifier transistors, which these are 012050s, and they cross over to a NTE 121, which I think is a PNP. It's germanium, and I as you can see right here, this looks like a diode. It looks like it could be a resistor, but I'm not really sure what it was. It's burnt. I don't know why they would put a diode on there, maybe to drop the voltage. But it looks like they're feeding the voltage into the collector of this. And they're taking the regulated voltage out of the emitter, which is, I think, is kind of unconventional, but I guess it works. And if you look right here, I'm guessing this is a Zener diode, because if you look at this network here, we got, okay, one side of this Zener diode is connected to chassis ground, the other goes to this tie point here through a 220 ohm resistor onto what is this? It would be positive 25 volts. And then right here at this tie point, they got a 100 ohm resistor, and going to, this has got to be the base. That's how they're regulating that 25 volts. And the only thing it's regulating here is just this one wire. There's only one thing tied to it, and I traced it back. It goes to this Molex connector right here, and the second one to, it would be the left. If we go back to the organ here, yeah, and I've traced it back to this Molex here, and it goes to this gray wire right here, and that wire, I've traced it all the way up, and it's going to the upper section of the keyboard here, and I have yet to discover where that wire goes. I don't know if something else burnt up to there, or because of the failure of that diode network, maybe it was just passing some AC and it just got overloaded. The transistor, as you can see, I'm gonna have to take all these boards out. I'm gonna take them out, and I'm gonna wash them off with the paintbrush and soapy water. It's gonna be quite a challenge to get all that, but I have to take all of that out. This organ here, this certainly was not made to be serviced very easily, and maybe that's one of the reasons why it became to be so hated. I mean, the only organs that people really like are the tone wheels, they have a distinct sound. They're certainly more sought after. But anyways, that'll be on my next video when I take all of that out and clean it up. I don't know. I don't have a whole lot to take out. I could label these wires right here. Probably these I won't have to label because they're kind of, I'll just take a picture. It's pretty self-explanatory. They're all, whoops, tied up. This went here. That is a voltage source right here. So we'll just put that back. Try to put it back. Okay, I'll get that later. I know where that goes. But anyways, maybe I'll label it right and left or something. That won't be too hard. Label these other wires, and then these are, you know what, I don't know what I'll do. I may have to cut these wires right here, but that's pretty easy to understand how they're connected. And then I'll just pull all those wires up there, and then I will for sure, I think I'll make a plate for all of these circuit boards so that they're all maybe on some type of standoff or something, so if I ever have to take it out again, it'll be a whole lot easier. Make some connectors for these wires. So this is a challenge I'm in way over my head. But back to this. I've checked these transistors here. They seem to have a little leakage between the emitter and the collector, which I don't usually see on silicone transistors, so maybe that's normal. And this transistor, it checks the one that's regulating this 25 volt. It seems to be the same, so maybe I'm good there. I'm going to plug this in and see what kind of voltages I get out of here, and see if that transistor works. I really should replace these capacitors. That's probably my first step, really, because when I did turn this on, I heard some humming, so these electrolytics are probably shot. So that'll be my first step, is to replace, at the very least, these electrolytics, especially for the power supply, because I'm sure they're leaky, and maybe they caused all the load on these diodes. And I'll also replace these diodes too. Probably just get some good old 1006s, and I should be good right there. So thanks for watching. If you want to leave some comments and hopefully lead me in the right direction, I'd sure appreciate it. Thanks for watching.